So now in section 2 and 3, our goal is to prove that two triangles are congruent. And tomorrow, when you get into section 2, day 2, you'll start to talk about different properties that we can use to prove that these triangles are going to be congruent. Today, we're just going to focus on the theorems and postulates that we can use to prove triangles congruent. And two of them that we can use today is, I can prove triangles congruent with SSS, and I can prove triangles congruent with SAS. Now, what do you think the S and the A are going to stand for? What do you think? What pieces make up a triangle? What is a triangle made up of? Sides and what? Sides and angles. So S is going to stand for sides, and angles is going to stand for that A up there. Okay? Now the first two that we're going to use is side, 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 and side angle side. So here's the deal. When you have two congruent figures, you don't need to sit and prove all parts are congruent. In triangles, you only need to prove 3 parts. And if they are ordered in a certain way, then you can prove that the triangles are congruent without having to do any extra work. All you have to do is prove maybe if there's 3 sides that you know that are congruent, then that's going to be the 2 triangles are the same. If you have a side and then an angle and a side, then you can also prove the triangle is congruent. So side angle side. How side angle side works is if you have a side, and then in between you have an angle, and then you have another side that's congruent, that means that the 2 triangles then would be congruent. So if you had a side, you had an angle in between those sides, and then you would need to be able to, and then you could prove that those are congruent. So we're going to look at that first example. We've got 2 triangles. I've got my 2 tick marks, 2 tick marks. I've got 1 tick mark, 1 tick mark. What else would I need to prove that these triangles are congruent by SAS? So I've got my side, What am I missing? The angle. Now the angle, it has to go into a specific place. It has to go between the 2 sides. So my angle would have to go here, and my angle would have to go here. So there's my 2 missing pieces. So if I mark those, that's showing that those 2 need to be congruent. You don't need to write a little congruent statement. C is congruent to, or G is congruent to Y. We can just mark those. Now we're ready to make our congruent statement. Actually, it wants us to put those in, so let's just do that. So it does need to say, we do need to say that G is congruent to Y. But if we were going to make a congruent statement, we could say like triangle HGI is congruent to ZYX, something like that. So now I'm taking a look at my second problem. It's kind of hard to see on my screen up here, but I've got a tick mark here, got an angle here, angle here. So far we've got a side, angle. What's the one piece I'm missing yet? Another side. Up here, up here. We still need another side. If I could prove those 2 sides were congruent, now I could prove the 2 triangles are congruent. Without even knowing about NQ, GT, angle G, angle T, I don't need to know all that stuff. All I need to know is if LG is congruent to MM, I can prove the 2 triangles are congruent. So LG, MM. All right, on to number 3. We'll finish with that one. So number 3, we've got an angle, a side, and a side. So right here, we've got an angle, side, side. But in order to prove 2 triangles congruent, we have to use the side angle side. So what information would I need? I would need this angle in between these 2. So that angle right there, I would need to know that angle T is congruent to angle V. And there would be my missing piece out. So side angle side, it's very important that if you have 2 sides with an angle in between, now you can start using that side angle side. Oftentimes, people will see this type of triangle. So maybe you see a triangle like this. Side, side, angle. You read that backwards, you can look at the word that it spells. Read it right to left. Okay? If you get that, SSA, ASS, there's no such thing as that. You can't ever do an SSA, ASS because those will not produce congruent triangles. So SAS, the angle, if you want to use SAS, the angle has to be between the two sides that you know. You know the two sides are congruent, that angle has to be between them. So no ASS and no SSA, so can't just write it backwards. All right, next we'll head down, we'll look at SSS. So now we can look at SSS coming into the party, and we're going to look at just proving would SSS or SAS, excuse me, prove the triangle is congruent. Write not enough information if you cannot use SSS and SAS. So here we're going to start getting into our proof thinking. So I'm looking at that first set of triangles, and I've got a congruent side. I've got another congruent side. I've got a set 2 down here, so I've got my sides. So in order to prove with SSS, I would need to know BA and DE are congruent to each other. Is there anything that's showing me anything that they're congruent? There's not. So there's no symbols, there's nothing, there's no statement saying, hey, BA and DE, they're congruent. So I cannot use SSS in this case. But look at your sides. Which angle would I have to know to prove SAS? The C stuff in here. All that's C. But there's no markings there. But there are some things that you can prove without markings. You don't need markings to prove some things. And this is one of those cases where if you have an X formation, you've got an angle and an angle on opposite sides, we can prove those are congruent. What type of angles are those called again? Vertical. So we can prove that BCA, DCE are going to be congruent because they are vertical. Now, this is important to know. You don't have markings, you can still prove that those angles are congruent. Anytime you have an X formation, it's just a postulate, it's known, they're going to be congruent no matter what. So we do have SAS in this case. You don't need markings to prove vertical angles. On to B. Looks like we've got a side of 2, side of 2, side of 1, side of 1. Now, in order to prove SSS, we would need to know DB in here is congruent to DB. Now, there's another thing we can prove without using any markings. If both lines, or excuse me, if both triangles share the same side, and that side is exactly the same on both triangles, guess what? They're what? It's congruent. So we know that since they're like kind of stacked on top of each other, we've got DB shared on the other triangle as well. This third side is going to be the side we need to prove SSS. Now, what is that is called? It's called the reflexive property. So the reflexive property is used when we're going to prove that two lines are part of both triangles, or excuse me, one line is part of both triangles, and that's going to then prove that that third side is also congruent. So we're going to say for this one is S, S, and S. Okay, so you can kind of take a look at the rest of the problems. 11. Be careful with 11. You got a side, and then an angle. So think about what that is. Side, side, angle. You flip that around. SSA. What does it spell? Not the good word. Not the good word. So anytime you spell ASS, it's wrong. You can't use ASS to prove anything. So I'll tell you 11. 11 is not enough info. Not enough information. Not enough info because SSA, ASS does not work. All right, so I will come around and help out with 4142. So you got about 10 minutes. Hopefully you should be able to finish 4.2. But to stay on pace, we should be on 4.2 day 1. Tomorrow, 4.2 day 2. So you will